So, what if the way we measure the age of our own planet is fundamentally wrong? Today we're diving into a really wild hypothesis from our source material that suggests Earth's history wasn't written slowly in stone, but was actually forged in a series of cosmic explosions.
You've heard it a million times, right? The Earth is billions of years old. It feels like one of those bedrock facts of science. But have you ever really stopped and thought, wait, how do we know that? I mean, how do you actually take the temperature of a planet that old?
Well, the answer, traditionally, lies in a kind of atomic clock that's built right into the rocks themselves. It's a method called radiometric dating, and the idea behind it is actually pretty elegant. You've got these radioactive elements that break down, or decay, into other elements, and they do it at a super predictable, constant rate. So by measuring the ratio of the original parent element to the new daughter element, scientists can calculate how much time has passed. Simple, right?
And let's be clear, this isn't just some minor tool. It is the absolute foundation of modern geology. The entire timeline we learn in school, with all the eons and eras, it all rests on one critical assumption: that this atomic clock is perfect, that its ticking has never, ever changed, no matter what. But here's where the source material we're looking at today just throws a giant cosmic wrench into the whole machine. It asks a really provocative question. What if that perfect, unchanging clock isn't? What if you could hit it so hard that you not only break it, but you make it spin completely out of control? So to really understand this argument, we have to start where it starts, by looking at the evidence that suggests there might be some problems, the cracks, the puzzles, the things that just don't quite add up in the conventional timeline. The source kicks things off by pointing to a potential problem with the process itself, something called confirmation bias. It highlights this idea that when a rock is dated and the result doesn't fit the age everyone expects it to be, that result sometimes gets tossed out as an error or contamination. The argument is, if you're only keeping the dates that are in the correct park, are you really proving the theory, or are you just filtering the data to fit it? And then you get to the really weird physical evidence. I mean, things like preserved soft tissue, actual stretchy, pliable tissue found inside dinosaur bones that are supposed to be tens of millions of years old. Or detecting carbon-14 in those same fossils, which is a huge problem because carbon-14 has a short half-life and should be totally gone after a few 100,000 years, max. The source claims these aren't just one-off mistakes. They're symptoms of a much bigger issue. Okay, so if the clock is broken, what broke it? Well, the source material points to a suspect with an almost unbelievable amount of power. The hypothesis, in a nutshell, is this. The culprit is giant asteroid impacts. We're not just talking about the one that wiped out the dinosaurs. We're talking about a history of impacts so unbelievably violent that they didn't just gouge out craters. They actually warped the fundamental physics of the planet. And the kind of energy we're dealing with here is just staggering. Take a look at this number. The source estimates that the Vredefort impact in South Africa unleashed about 10 to the 33 giga-electron-volts of energy. To give you some kind of perspective, that is orders of magnitude more energy than what holds the nucleus of an atom together. It's a truly cosmic scale of force. And this right here is the absolute core of this whole controversial idea. The source argues that an event this powerful isn't just geology, it's nuclear physics. It creates a situation so extreme that for a brief, terrifying moment, that fundamental constant of radioactive decay might not be constant at all. I know what you're thinking. How can a space rock hitting the ground possibly change the laws of physics? It sounds like something out of a comic book, but the source material actually proposes a specific physical mechanism for how this could happen. So it breaks down into a few steps. First, you get the massive impact, unimaginable pressure and heat that instantly vaporizes rock, creating a plasma. Now here's the key part. In that super dense, chaotic plasma, electrons can actually get forced into the nucleus of an atom. The claim is that this forced interaction makes the nucleus unstable, causing it to decay at a ridiculously accelerated rate. The source also brings up another piece of the puzzle, a proposed phenomenon called the piezonuclear effect. The basic idea is that if you put certain crystals, like quartz, which is everywhere, under insane mechanical pressure, they can generate incredibly powerful electric fields. We're talking fields potentially strong enough to trigger nuclear reactions on their own and mess with that atomic clock even more.
And if you're having trouble picturing just how extreme these conditions are, this table really drives it home. For a few brief moments, the conditions right at the impact site, the temperature, the plasma density, are comparable to the core of our own sun. The source is essentially arguing that for a split second, a star is born on Earth, and it brings the physics of a star with it.
So here's the bottom line of this proposed mechanism. The atomic clock in the rocks doesn't just get reset to zero by the heat. That's the old idea. This new idea says the clock is forced to run incredibly fast, packing what should be millions or even billions of years of radioactive decay into just a few moments.
Okay, so let's just step back and think about this. If, and I know, it's a monumental if, but if this hypothesis is correct, the implications are absolutely off the charts. It doesn't just tweak the timeline, it blows the whole thing up and forces us to start over.
This would be a massive shift away from the idea that's dominated geology for 2 centuries, uniformitarianism. That's the principle that everything happens slowly and gradually, that the present is the key to the past. This hypothesis throws that out the window in favor of catastrophism, the idea that Earth's history is defined by sudden, violent, large-scale events, with giant impacts being the primary driver.
This idea would also totally reframe the fossil record. Instead of fossils being neatly layered according to when they evolved and died, the source suggests they were sorted hydrodynamically during global catastrophes. Think about it. In a massive flood, an animal's final resting place would have more to do with where it lived, how dense its body was, and how well it could swim than with what geological era it belonged to.
And according to this viewpoint, there's a fascinating pattern in the data that could back this up. The source points out that, generally speaking, the bigger the impact crater, the older the radiometric age assigned to it. The hypothesis says this isn't a coincidence at all. A bigger impact equals more energy, which equals more accelerated decay, which results in a much older apparent age for the rocks.
The implications even stretch into our own biology. The source brings up genomic studies that have found a weird sudden spike in human genetic mutations sometime between 5 and 10,000 years ago. It floats the idea that this mutation peak wasn't from a change in diet or anything like that, but from an intense burst of radiation from these catastrophic impact events that would have blasted all life on Earth.
So, to put it all together, the central claim here is that the geological timeline we've all learned may be a grand misinterpretation. We think we're reading a calendar that tracks the slow, steady passage of time. But if this hypothesis is right, we might actually be reading the Richter scale of ancient catastrophes. The age of a rock isn't a measure of time, but a measure of energy from an impact.
It is a deeply provocative and frankly unsettling idea. It challenges the very foundation of how we see our world and its history. And it leaves us with one heck of a question. Is the story of Earth written by the slow, patient hand of time, or by the sudden, violent blow of a cosmic hammer?